To get started,
Yeah, probably.
Anything else change that? Probably. That's a good one. Was it? Not so good. You like it?
okay. OBNXIX. Unit 3. Hear that? Yep. Join PB.com. Unit 3 talks about correlation and regression for what are called bivariate data. We've done univariate data, and there are summary statistics for univariate data. Univariate data we did like mean, standard deviation, median, IQR, the 5-number summary for a set of data. That was a one variable data set. A bivariate data set has 2 different variables, an explanatory and a response variable. Bivariate, 2 variables. So we're talking about displaying bivariate data set in a scatterplot. The association between 2 different variables, calculating correlation, linear regression, calculating the correlation of trend lines. In this unit. We'll get started on these slides today, talking about how to analyze a scatter plot. And then we'll look at some correlation starting tomorrow. I calculate what's called the correlation coefficient. I have group standards 9 and 10. Together here, getting started for this next set of slides. We're going to look at the equation and ideas behind correlation, actual correlation score for a set of bivariate data. Correlation coefficient talks about the R value. I don't know if you've used the R value before. R varies between -1 and 1. The closer R is to ±1, the stronger the relationship is between the data. The closer your R correlation coefficient is to 0, the weaker the relationship. Today's focus is actually going to be kind of what is in standard 10 here. How do you evaluate a scatter plot? What do we look for when looking at a scatter plot? Displaying a bivariate data set. As a learning target, creating a scatter plot, describing correlation for a set of bivariate data. Okay, so a scatter plot is just a display in which the values of 2 different quantitative variables, otherwise called bivariate data, are plotted along 2 axes. So look at the scatter plot on your screens. What are the 2 variables? What's being graphed along the x-axis? Height in inches. What's being graphed along the y-axis? Weight in pounds. I want to see the relationship between the height and weight for this data set. So I plotted weight versus height. Does any change in height cause some change in the weight?
Yes. Yes, sir.
Based off of this trend, I would expect taller people to weigh more. As height increases, so does the weight. So similarly does the weight. I can look at any correlation between the 2 variables by looking at the trend in the scatter plot. In the middle of that scatter plot is what's called a trend line, or a line of regression. A trend line will be helpful in making some predictions for the weights of people based off of their height. So for example, if I know a person is 60 inches tall, I can use the trend line to predict their weight. 60 inches tall, you should weigh about 90 pounds. For somebody who's 60 inches tall, we expect them to weigh about 90 pounds. Now there's some variability. Don't some people weigh more than I would expect, and some people will weigh less than I expect? Yes. So the trend line is describing the data, but there's some variance, there's some error or residual. There is some variance from what I would expect based off of the trend line image. In looking at a scatter plot, here are kind of the 4 things we're looking for. I've got them graphed or written out on this back wall here. What to look for when analyzing a scatter plot. What to look for when describing the relationship between a set of bivariate data, y versus x. Or in the case of the scatter plot that came before, weight versus height. Direction. Are the data increasing or decreasing from left to right? In other words, is there a positive association or a negative association? Go back to this scatter plot. Is the trend line, is the data increasing from left to right or decreasing? Increase. So as heights increase, I would expect the weight to similarly increase. That is called a positive relationship. If it was decreasing, it'd be a negative relationship. There's a direct correlation. As one variable increases, so does the other. As heights go up, so does the weight. If there's a negative correlation, that's just the opposite. As one variable increases, the other decreases. A good example of that I've always kind of thought of before is the relationship between the number of times you brush your teeth per day and the number of cavities you have. If you brush your teeth more, wouldn't I expect you to have less cavities for the most part? Yeah, that's a negative association because of that indirect relationship between those 2 variables. As one goes up, the other goes down. In a positive association, the trend line is going up from left to right. It has a positive slope. So as one variable increases, the other similarly also increases. Okay, direction is either positive or negative. Let's also talk more about form. Does the data form a straight line? Is the data linear? Does the data form some sort of curve? No longer a line? Is it a nonlinear relationship? Or is there no form, no general pattern? So if I graph a couple of scatter plots really quick here, I'll put 2 variables, x and y.
Whenever you're ready to send up.
Go ahead.
Thank you.
Is that a linear, non-linear, or no form scatter plot?
Linear.
Linear, right? It looks like the line forms pretty much the entire relationship between the 2 different variables. A line describes the relationship between the 2 variables. It's a negative linear relationship. Linear. How about the next scatter plot? Is this linear? No, it's not a line, right? But doesn't it have some sort of form? Almost like a curve? It goes up and then down. Y increases and then decreases as x increases. This would be a nonlinear form. There's some sort of curve. As x grows, y grows, and then it goes down and it decreases. Y changes direction as x increases. Nonlinear doesn't really have a direction because it's nonlinear, right? How can I describe the association as positive or negative if it goes up, then down. If you have a nonlinear scatter plot, it doesn't have a direction, obviously. How about that type of scatter plot? No form. As x grows, I have no idea what y does, because sometimes y is really large for big x values, sometimes y is really small for big x values. This has no form, no pattern. There's no curve or line that describes the trend of the data. All right? Negative linear relationship. Strong nonlinear relationship. No form at all in the scatter plot. There is no prediction for y that I could make based off of what particular x value I might have. Y has a lot of variance for a particular x value. Right. How strong is the relationship? Let me look at this scatter plot I drew here. How strong is this relationship? How good is a trend line at describing the data? I draw a little trend line right through the data. Is that a pretty good fit? Yeah. The better the fit, the stronger the relationship, right? What if I put a few more points out? Is that line as good a fit now? No, because there's more variability in the data, right? Yep. The predictions that I would make for a given x value are going to vary more widely. This value here could be as high as what I have above or down below, so there's more error in my prediction. The less strong the relationship is. We've got direction as positive and negative. I've got form as linear, nonlinear, and no form. Strength would be weak, strong. An outlier. What does an outlier mean? Something's an outlier. It doesn't really fit the data set. It stands apart. It's kind of an atypical data point given the rest of the bivariate data set. It's some dot in the scatter plot that's off by its lonesome. Going back to this first scatter plot, I had a positive, linear, pretty strong relationship. I don't really see a few outliers. I don't really see many outliers, but I mean, this one's kind of weird, isn't it? This person weighs more than I would expect for their given weight. Most of the data is described by that trend line, so there aren't really a whole lot of them.
I don't think this is very accurate.
I think it's for children, so it's not like for adults, right? It's weight and height of children. So like elementary and middle school age kids. All right. We've talked about variables before. Here's just a little bit more about how to arrange the variables when it comes to making a scatter plot. Explanatory and response variable, that's just the same as your independent and dependent variable. The value of your dependent variable depends on the value of your independent variable, just like the value of the response variable depends or is predicted by the explanatory variable. What changes in the response variable can be measured by changes in the explanatory variable. Because we're looking at two different variables, the response variable, just like the dependent variable, is placed on the y-axis in a scatter plot. The explanatory predictor variable is the independent variable, so put it on the x. Based off of what you're trying to do with the data set, there could be some kind of variation on which one you want to put where, which variable is the horizontal axis, which variable is the vertical axis. Well, for the most part, think about it in terms of what depends on what. I'm looking back at this scatter plot here. They're trying to predict the weight based off of the height. They're not trying to predict the height based off the weight. So as I'm trying to measure the weight based off the height, the weight is the response variable on the y-axis. The height is your explanatory variable on the x-axis. Questions you guys have so far? Sure, of all of those Scatterplots before, but it's pretty easy. All right. I would like to practice looking at a couple of Scatterplots here in these next couple slides, where you actually provide some responses to what's the direction, form, strength, or outliers. On these next couple slides, there's going to be some prompts for you to respond to. Everyone got it? Good. All right, let's try the first one. Move the dot to the scatter plot with a positive direction. There's two scatter plots. One is plotting penalties versus points in a game. The other is plotting the price of an engagement ring versus the size of the stone, the size of the diamond and carats. Which scatter plot has a positive direction? Which scatter plot is directly related for the two variables? Take the little dot, move it to which one you think. So obviously everyone's going to hopefully pick the one to the right. Why did you all pick that one? It's going up, right? It's a direct relationship. As the size of the diamond in the ring grows, wouldn't you expect the price of the ring to also go up based off of what you're looking at in those data points? Yeah, makes sense. The other one is the negative relationship, the indirect relationship, in other words. The more points you score, I'd expect you to probably have less penalties in the game, which is why those data points are going down from left to right. Can you describe direction in a nonlinear scatter plot? Does a nonlinear scatter plot have direction? Come back here. Do either of these two scatter plots have direction?
Yes.
No. How can nonlinear have direction? Because it goes up and down. This one has no form. This one doesn't really have a direction at all. No. I can only describe direction when it doesn't change direction, like in a linear relationship. This is a negative linear association. Those two, the left one is negative, the right one obviously is positive that you chose. That make sense? Yep. Cool. Next prompt. Describe the form. Is it linear, nonlinear, or no form? I think this is salary and pick number for draft, like an NBA or an NFL draft. I think salary is measured in like hundreds of thousands of dollars. And pick number is like your selection number in the draft, where I pulled this from. All right, I've got 2 that say linear and 6 that say nonlinear. Let's go back to the graph here. I think the correct answer is nonlinear. Why is it nonlinear?
No line.
Not a line, it's a curve, right? Why would it be a curve based off of what the data is? Think about the NFL or the NBA draft. Is there a big difference in the salary they're going to make between like the 1st, the 5th, and the 10th selection? Like the first person makes a lot of money, right? The second person still makes a lot of money, but isn't it significantly less than what the first person got? And like by the time you get down to like the 10th, it's still a lot less, right? So the first couple selections, there's a wide variability in their salaries. But then after you get to like the 30th or the 40th or the 50th, does it really, like there's a lot less variability, right? They're still making relatively the same amount of money. So there's a large difference in the salaries to begin with, and then smaller differences the further down you go. Why this is correct. kind of an exponential decay almost. Number 3, describe the strength as weak or strong for the relationship in the scatter plot shown. Is it weak? Is it strong? I think it's also saying positive and negative too, right? So if you select weak, make sure you pick either weak positive or weak negative. Pick strong, select the correct strong positive, strong. Think about strength, think about how good the line is at measuring or describing the data. Does the line describe almost the entire relationship for these two variables? We're looking at age versus internet usage. I see a little bit more split. We're obviously all answering negative. 5 of us said strong. 3 of us said weak. I think I could make a case for both. Those of you who said strong, why did you say strong?
Because most of them are right on the line,
Except for a few outliers. Doesn't the line go through pretty much every single point in the scatter plot, or relatively close to? Yeah. Those of you who said weak, why did you say weak strength?
Flips over the outside of the line.
So you're saying sometimes the data points are on top of the line, sometimes the data points are below the line, right? So there's some variability there. Okay. What else? Why might other people have said weak? Are there points kind of set apart from the line?
Yeah, there's a few outliers.
Few outliers, right? Isn't this person using the internet a lot more than what their age group would typically indicate? And this person's using the internet a lot less than what their age would typically indicate. Tomorrow, we're going to talk more about what's called the R value, or the correlation coefficient for a set of bivariate data. That's actually given up on top here in red. R for this set of data is equal to negative 0.87. R is a measure that varies between negative 1 to 1. The closer R is to positive 1, the stronger the positive association. The closer R is to negative 1, the stronger the negative association is. If R is closer to 0, the less strong. There is no form in the data. If an R value is about negative 0.87, it's a pretty strong relationship. So sometimes the R value can tell you how strong the relationship is between two. Negative 0.87 is pretty close to negative 1. So a negatively sloped line does a pretty good job of describing the relationship between the data. I think I had one more slide before I was done here. We'll come back and finish this up tomorrow. Here is one more scatter plot that shows knee versus ankle diameter. Can any change in knee diameter be explained in terms of the ankle diameter?
Porter
Flag in
Doggett,
outliers.
report to the secondary office. Porter Doggett, please report to the secondary office.
What?
Move the red flag to an outlier in the scatter plot. I'm looking at knee diameter versus ankle size. Can any changes in ankle size explain any changes in terms of the knee size? I think I said that backwards. Can any changes in knee size be explained by changes in ankle size? I see one flag. Does that mean that everyone put it in the same spot? Yeah, pretty much. They all overlaid over that top dot. Everyone put it on this top point right here. I think of maybe these two as being kind of outliers, right? They have pretty large kneecaps given the size of their ankles. Given this ankle size, I'd expect your kneecap to be this small. Yours is significantly bigger. So it's an outlier considering or when compared to the rest of the data set. It's a data point set apart from the rest as an outlier. All right, let me end that here. Actually, hang on a second. Next slide, click on that link. And take you to the practice problem. I'd like you to do 1 through 4. 1 through 4 for the S9, 10 practice problems. If you want to also, since you have your laptops open up, pull up the key. It's on schools. You guys didn't link it in this slide. Get started with practice. I'd like you to get the first 4 done before we move on to correlation.
Would you like to make a copy?
I don't think you have to make a copy.
I want to write it down.
Okay, then make a copy.
I'll make it.
Okay.